5.2 RBI. 5.2.1 General. An RBI analysis may be used to determine inspection intervals or due dates, and the type and extent of future inspection examinations. The RBI analysis, when conducted in accordance with API 580, shall include all the inspection planning elements noted in API 580 section 5.2. When the user owner chooses to conduct an RBI assessment, it shall include a systematic evaluation of both the probability and the associated consequences of failure, in accordance with the requirements of API 580. API 581 provides a set of methodologies for assessing risk, both POF and COF, and for developing inspection plans that are consistent with key elements defined in RBI API 580. Identifying and evaluating potential damage mechanisms, current equipment conditions, and the effectiveness of the past inspections are an important step in assessing the probability of piping failure. Identifying and evaluating the process fluids, potential injuries, environmental damage, equipment downtime are important steps in assessing the consequences of piping failure. Identifying the integrity operating window for key process variables is an important adjunct for RBI. Probability assessment. The probability assessment shall be in accordance with the requirements of API 580 and shall be based on all forms of damage that could reasonably be expected to affect equipment in any particular service. Additionally, the effectiveness of the inspection practices, tools, and techniques used for finding the potential damage mechanisms shall be evaluated. Other factors should be considered in probability assessment include appropriateness of the materials for construction for the damage mechanisms, equipment design conditions relative to operating conditions, appropriateness for design codes and standards utilized, effectiveness of corrosion monitoring programs, the quality of maintenance and inspection quality assurance quality control programs, both the pressure retaining and structural requirements, operating conditions both past and projected, and review of potential fouling as it impacts damage mechanisms, prior mechanical corrosion of failure history of the piping system circuit, review and inspection history. 5.2.3 Consequence assessment. The consequence of release is dependent upon the type and amount of process fluid contained in the equipment. The consequence assessment shall be in accordance with requirements of API 580 and shall consider the potential incidents that may occur as a result of fluid release, the size of a potential release, and the type of potential release, including explosion, fire, or toxic exposure. The assessment shall also determine the potential outcomes that may occur as a result of the fluid release or equipment damage, which may include health effects, environmental impact, additional equipment damage, and process downtime or slowdown. 5.2.4 Documentation. It is essential that all RBI assessments be thoroughly documented in accordance with the requirements of API 580, clearly defining that all factors contributing both the probability and consequence of failure of the equipment. After an RBI assessment is conducted, the results can be used to establish the equipment inspection plan and better define the following: the most appropriate inspection and NDE methods, tools, and techniques, the extent of NDE, percentage of equipment to examine, the interval of due date for internal, where applicable, external, and on-stream inspections, the need for pressure testing after damage has occurred and after repairs, alterations have been completed, the prevention and mitigation steps to reduce the probability of consequences of equipment failure, repairs, process change, inhibitors, etc. Frequency of RBI assessments. When RBI assessments are used to set equipment inspection intervals or due dates, the assessment shall be updated after each equipment inspection as defined in API 580 section 15. The RBI assessment shall be updated at least every 10 years or more often if process or hardware changes are made, or after an event occurs that could significantly affect damage rates or damage mechanisms. The RBI assessment shall be reviewed and approved by the appropriate qualified personnel per API 580 and inspector. 5.3 Preparation for inspection. 5.3.1 General. Safety precautions shall be included when preparing piping systems for inspection and maintenance activities to eliminate exposure to hazardous fluids, energy sources, and physical hazards. Regulations, those administered by the U.S. Occupational Safety and Health Administration, OSHA, govern many aspects of piping systems, and inspections shall be followed where applicable. In addition to the owner-user safety procedure, shall be reviewed and followed. API 574 for more information on the safety aspects of piping inspection. Procedures for segregating piping systems, installing blinds, blanks, and tightness testing should be an integral part of the safety procedures for flange connections. Appropriate safety precautions shall be taken before the piping system is open. In general, the section of piping to be open and should be isolated from all sources of harmful liquids, gases, or vapors, and purged to remove the oil and toxic or flammable gases and vapors. See API 574 for more information on the equipment preparation and entry aspects of piping inspection. 532 Records Review. Before performing any required inspection, inspectors shall familiarize themselves with the prior history of the piping system for which they are responsible. In particular, they should review the piping system prior to inspection results, prior repairs, current inspection plans, or other similar service inspections. Additionally, it is advisable to ascertain recent operating history that may affect the inspection plan. The types of damage and failure modes experienced by piping systems are provided in API 571 and API 579-1. Inspection for types and locations of damage modes and deteriorations and failures. Piping system damage types. API 571 describes common damage mechanisms and inspection techniques to identify them. Some example mechanisms applicable to process piping are as follows: general and localized metal loss, sulfidation and high temperature H2S, H2O corrosion, refer to API 571. Oxidation, refer to API 571. Microbiological induced corrosion, MIC. Naphthenic acid corrosion, corrosion, galvanic corrosion, atmospheric corrosion, corrosion under insulation, cooling water corrosion, boiling water condensate corrosion, soil corrosion, ammonium bisulfite and chloride corrosion, carbon dioxide corrosion, surface connected cracking, mechanical fatigue cracking, thermal fatigue cracking, caustic stress corrosion cracking, polythionic stress corrosion cracking, sulfide stress cracking, chloride stress corrosion cracking, subsurface cracking, hydrogen-induced cracking, wet hydrogen sulfide cracking. High temperature micro fissuring, micro void formation, and eventual micro cracking. High temperature hydrogen attack. Creep stress rupture. Metallurgical changes, graphitization, temper embrittlement, hydrogen embrittlement, and then there's blistering, which is hydrogen blistering. The presence of potential of damage in equipment is dependent upon its material of construction, design, construction, and operating conditions. The inspector should be familiar with these conditions, with the causes and characteristics of potential defects and damage mechanisms associated with the equipment being inspected. Detailed information concerning damage mechanism, critical factors, appearances, and typical inspection and monitoring programs are found in API 571. Other sources of information on damage mechanisms include the bibliography. Additional recommended inspection practices for specific types of damage mechanism are described in API 574. Areas of deterioration for piping system. Each owner shall provide specific attention to the need for inspection of piping systems that are susceptible to the following specific types of areas of deterioration: injection points and mixing points, dead legs, CUI including ECSCC inspection, soil to air interfaces, soil corrosion and buried piping, specific service and localized corrosion, erosion, environmental cracking, corrosion beneath lining and deposits, fatigue cracking, creep cracking, freeze damage. Contact point corrosion. Brittle fracture is not normally mitigated by inspection, but the owners shall be aware of the potential for brittle fracture for some material of construction is exposed to specific temperatures and stress conditions and manage the risk appropriately. Managing with process controls. Refer to API 571 and 574 for more detailed information about the above noted types of areas of deterioration. 5.5 General types of inspection and surveillance. 5.5.1 General. Different types of inspection and surveillance are appropriate depending on the circumstances of the piping system. These include the following types of inspection and inspection focus areas: internal visual inspection, on-stream inspection, thickness measurement inspection, various NDE inspections, external visual inspection, vibrating piping inspection, supplemental inspection. Inspection shall be conducted in accordance with the inspection plan for the piping circuit or system. Refer to Section 6 for the interval and frequency and extent of inspection. Corrosion and other damage identified during inspections and examinations should be characterized, sized, evaluated per Section 7. Revision to the inspection plan shall be approved by the inspector or piping engineer. 5.5.2 Internal visual inspection. Internal visual inspections are not normally performed on piping. When practical, internal visual inspections may be scheduled for systems with such large diameter transfer lines, ducts, catalyst lines, or other large diameter piping systems. Such inspections are similar to nature of pressure vessel inspections and should be conducted with methods and procedures similar to those outlined in API 510 and API 572. Remote visual inspection techniques can be helpful when inspecting piping that is too small to enter. An additional opportunity for internal inspection is provided when pipe flanges are disconnected, allowing visual inspection of internal surfaces with or without the use of NDE. When piping flanges are disconnected, the gasket, surface, studs, and nuts should be examined for the signs of deterioration. Removing a section of piping and splaying it along its center line also permits access to internal surfaces where there is need for such inspection. On-stream inspection. On-stream inspection may be required by the inspection plan. All on-stream inspections should be conducted by either inspector or examiner. All on-stream inspection work performed by an examiner should be authorized and approved by the inspector. When on-stream inspection of the pressure boundaries are specified, they shall be designed to detect the damage mechanism identified in the inspection plan.